All right, now the next thing that we're going to do is we're going to work on Google Cloud Store, okay, which is Google Cloud Storage, yeah, which is GCS. And on GCS, what we're going to do is we're going to create a bucket, okay, and you can think of GCS as a giant hard drive in the cloud that never runs out of the space, okay, and is always online, right? Now the next question you might think as to, hey, why do we save it to GCS at all? Okay, why not keep the data in memory? Okay, so if our Python program crashes halfway through downloading, okay, roughly there, let's say for example there are 144 research studies, we might end up losing everything that we have only kept in the memory. So what we're going to do is we're going to store it on cloud. We're going to save it on Google Cloud Storage. So even if something crashes, the studies that were downloaded are already safe. Okay, now typically we're going to work on something called as raw versus processed pattern here. And why we save the data twice? Raw is nothing but the data that we have exactly received, or the response that we have exactly received from the API as it is. It is completely original, completely untouched. And you can, and the next is processed. What is processed? Process the cleaned up version of the document. If you can recall, in document parser we had written a lot of data cleaning code. Document parser will be running upon the raw API and will be giving us the cleaner version of the code. Yeah, and that is what we're going to do, right? So in case of our parser, document parser.py has a bug and it cleans the data incorrectly, we have not lost anything, okay, because we already have the original files or the raw files saved, right? Which is, and this is the real production safety pattern, okay, which is fantastic. Okay, this is how the folder structure might look, or not might, will look in our bucket. So in raw we're going to have studies, and in studies we're going to have the JSON, which is the raw, exactly how clinicaltrials.gov API is going to send us. Then again in raw we're going to have papers.json, like raw papers, which is what PubMed is going to send us. Then in process we're going to have the cleaner version of this JSON, of the above two JSON files. As simple as that. Now these studies are going to use the parse study class, and the papers are going to use the parse paper class. Fantastic. Yes, let's proceed with building this particular document code. So I'm going to start with importing JSON. I'm going to import async IO. Then from typing I'm going to import any. Yeah, then from google.cloud I'm going to import storage. Okay, and this is Google's official Python library for talking to Google Cloud Storage. Okay, if this is not working in your case, you can just do a pip install google-cloud-storage and run it. Okay, then from config.settings I am going to import settings. From config.logging config I am going to import setup logging. Okay, then from ingestion, okay, from ingestion.document parser file I'm going to import parsed study that we use and parse paper, both of them. Okay, and then let me just create this one, okay, which is setup logging. Okay, and here it's just going to take the name. Okay, and the name here, okay, this particular name here is going to be what? It's going to be ingestion.gcs_store. Okay, now what are going to be the folder paths inside the bucket? Okay, let's focus on that. Okay, now yeah, so what I'm going to do is I'm going to say prefix raw studies. Okay, and I'm going to store them as raw/studies, then prefix /raw/papers, and I'm going to store them as raw/papers. These are where your raw data is getting yeah. Then prefix processed studies, okay, which is cleaned data, is going to be stored, and prefixed processed papers as well. Okay, so this will be processed slash studies, and this will be processed slash papers. Fantastic. All right, now let's do one thing. Let's build the GCS store class. Okay, so in GCS store class, first and foremost, I'm going to define the class, which is GCS store. Okay, and what does this class do? This handles saving the data to and loading the data from cloud storage. Okay, let me just put it here. Okay, so what it is going to do, it is going to handle saving the data to and loading from the GCS. Now here, why we use async io.to_thread throughout this file. So Google's official library is synchronous in nature. Okay, which means when you ask it to upload a file, or your whole program is going to freeze, and it is wait unless and until this upload is going to be done, which is not good for production pattern, right? But our Mosaic system, now I am calling it Mosaic, I have named it Mosaic, which is our agentic system, is built to be asynchronous in nature, right? Which means we want our program to be able to perform other things while waiting for the slower operations like upload to finish. And that is the reason why we're going to use async io.to_thread. What it does, it takes synchronous functions like GCS upload and runs it in a separate background thread, right, while letting our main program to run as it is. Yeah, which is great, right? All right, so let us define the constructor. Okay, and here I'll just say self dot client equals to, will create storage client. Okay, and I'll say project equals to settings dot GCP project ID. Okay, so what does this do? This is going to create connection to the Google Cloud Storage. Okay, and this does not immediately connect to the internet. It just sets up the object that knows how to connect. Okay, when we actually ask it to do something. So in general, it is just going to connect to your Google Cloud Storage. Okay, then let's take bucket. So I'm just going to say self dot client dot bucket. Okay, and I'm going to say settings dot GCS bucket name. Okay, what it is going to do, it is going to reference our GCS bucket, the one that we have earlier created in our GCP terminal. Okay, so it is going to access that. Okay, and with this, let us also log it. Okay, so I'm just going to say GCS store initialized. Okay, am I writing it right? Initialized. Okay, and then we'll just say we'll take the bucket. So where do we take the bucket from? I'll just say settings dot GCS bucket name. Okay, looks fine. And then I'll just say project equals to settings dot GCS project ID, GCS underscore project underscore ID. Okay, GCP, sorry, this should be GCP. Yeah, cool. All right, looks fine. Okay, and now what we're going to do is we're going to write a function to save the raw dictionary. Okay, save the raw study, not dictionary. Yeah, so I'm going to create a function which is async in nature. Let's say I'm going to call this as save raw study. Okay, and what does it take into consideration? It takes the NCT ID. Okay, then it takes the data dictionary. Okay, and this is the raw dictionary. This data dictionary is nothing but the raw dictionary, exactly as to how clinicaltrials.gov has sent it to you. Okay, nothing has been cleared or modified yet. And what does it give in output? It gives a string. Okay, what does this library will do? Let me just take it from here. Okay, this library is going to save the exact untouched API response from one research study. call this moment you receive the data from API before any cleaning or parsing happens, and this way even if the parser has a bug, the original is always safe. This is what it takes an argument. This is what it returns. What does it return? It returns the path inside the Google Cloud Storage where a file or that particular file was received. So this is that path. Okay, so we're just going to say prefixed raw studies because they are raw, and which is untouched, and nctid.json. Okay, so path followed by nctid.json. It's going to be a JSON output, right? Yeah, so for example, typically how the output might look like, let me show you that with an example. So typically if you see raw studies, raw/studies/nctid.json, this is how the GCS path will end up looking like. Okay, and then I'll just say await upload JSON. It will take the path, which is GCS path, and also takes the dictionary. Okay, looks fantastic. Let us also log it. So I'll just say logger.info, and I'll just say saved raw study. Okay, then I'll say, then I'll take nctid, just a minute, yeah, nctid, and we'll also give the path. Looks fantastic. Yeah, and finally what does this return? It returns the GCS path. Yeah, looks good. Yeah, now what we're going to do is, just how we have saved the study, we are going to save the raw paper as well, and the raw paper gets stored where? It gets stored in the prefix raw papers. Basically that is the path. Okay, so I'm going to create an async function called as save raw paper. Okay, it takes the pmid, which is again string, takes the data. Okay, it takes the data, and what does it give in the output? It gives the string. Okay, what does this function do? It does the same job that we have seen above. Okay, so it saves the exact untouched data from one PubMed research paper. Okay, same idea that we have done for paper, it is going to do it here. Okay, all right, so first and foremost it will take the GCS path. Okay, and let me say prefix raw papers. Okay, slash yeah, this will be slash, and here we'll take the pmid, which is public, like PubMed ID, and this will be also saved as JSON. Okay, that will be the path. Then I'll just say await self dot hyphen upload JSON. It takes the path, which is what? Which is your GCS path, and it also takes the data dictionary. Fantastic, looks nice. Let us also log this. Yeah, so I'll just say saved raw paper. Okay, and for that raw paper I need the PubMed ID as well, so I'll be getting that from here. Okay, and I also need the path, so I'll be just saying this as GCP path. Yeah, I think this is looking fine. This also returns the GCS path. Yeah, all right, this is fine. Now what we're going to do is we're going to write another async function which saves the cleaned, okay, or the parsed paper. Okay, just allow me a minute, let me just drink water. All right, looks fine. Okay, now let us write async function. We're going to call it as save parsed paper. Okay, then it writes self, it takes in the paper, okay, and returns what? Returns a string. Okay, let me show you the doc string. It saves the cleaned version of the paper, so it is going to clean it. Okay, what is the argument? It takes the parsed paper object, which is the clean typed version. Okay, and it returns the GCS or the Google Cloud Storage path where it was saved. Okay, this is pretty straightforward code. Okay, so it again takes the GCS path. Okay, it will take what? Prefix processed papers. Okay, followed by paper.pmid. Okay, so for that particular paper, it is also going to take the pmid. Okay, and the output is going to be .json. Okay, all right. Just a minute. Okay, this is fine. Okay, then I'll just say await. Okay, self dot something is off, it seems. Yeah, await self dot I'll just say upload hyphen underscore JSON. Okay, and then I'll just put in the path, which is GCS path, and I'll from this thing paper, which is going to do model.dump. Okay, all right, and then let us log it. So I'll just say logger.info. Okay, and I'll say saved parsed paper. Okay, let it register the pmid also, paper.pmid. Okay, and then I'll say path equals to GCS path. And then finally I'm going to return GCS path. Yeah, all right. Okay, we're going to now load the cleaned study back from GCS. Okay, so I'm just going to write async function, and what this is going to do is it is going to load the parsed study. Okay, and takes in the NCT ID, and what does it return? It returns a parsed study object, else it returns none. Okay, so what does it do? Okay, let me just take the explanation here. Okay, it loads the previously saved or a cleaned research study from the GCS. So it will now fetch the clean data, and this is reverse of saved parse study. We use this in processing layer when we need to read the studies and back into chunk and embed them. Okay, so all right, let's do it. So now it takes the GCS path. Okay, so I'm just going to say prefixed processed studies. Okay, and I'm just going to put in the NCT ID here, followed by .json. Okay, and then we're going to extract the data. So I'm just going to say await self dot download JSON, and I'm going to put in the path. Okay, all right, and if not data, okay, then we just return none, as simple as that. Okay, yeah, all right, and finally what does it return? It returns the parse study. Okay, I'll just say parse study from the so this asterisk data, it basically unpacks the dictionary into keyword arguments, right? For example, let's say you have let me just take the information from here. Yeah, see your data asterisk data, what it is going to do is it is going to unpack the dictionary into keyword arguments. For example, if your dictionary looks something like this, which means it is an NCT ID, then a title, etc., then this particular item, okay, is the same thing as writing parse study, NCT ID, etc. So you're just going to unpack this here inside the parse study object. Okay, as straightforward as that. Okay, and then what we're going to do is we're going to list all the studies that we have already processed. Okay, so I'm just going to say async or I'm going to create a function list of processed studies. Okay, just a minute. Yeah, and it just gives a list of string. And what does it do? let me fetch it out. What does it do? It returns a list of every research studies NCT ID that is currently saved in the processed folder of the bucket. And we use this later in the processing layer to know exactly which studies are available, to chunk them and to embed without needing to ask the database first. Okay, cool. And what does it return? It returns a list of NCT ID strings. Okay, so I'm going to create something called as blobs. Just a minute. Yeah, I'm going to say await async io dot to underscore thread. Okay, then I'm just going to say bucket dot list underscore blobs. Okay, and I'm just going to prefix set it as prefix processed studies. Okay, now here if you see, now you might ask what is blob. Now blob is a GCS terminology for a single saved file. You might have heard of Azure blob storage. Blob is nothing but Google Cloud Storage's own terminology of a single saved file. When it comes to list of blobs, this list blobs is actually synchronous in nature. Okay, so we are going to wrap it inside async io.thread. Okay, as explained at the top of the class. Prefix here means only show those files, okay, that basically start with processed / studies. Okay, and those are the only files we want. Let me just paste the explanation here. Yeah, all right. After this, what I'm going to do is I'm going to create an empty dictionary of NCT IDs. Okay, and now I'm just going to loop over all the blobs, which are single stored files or saved files. Okay, so I'm just going to say file name equals to blob.name.split. Okay, so what are we doing here? Okay, see, blob name actually looks like, you know, let me just fetch out. Just give me a minute. All right, so if you see, when it comes to blob name, this blob.name something looks like this one, because it is a fetch record of your JSON from processed and studies, right? So this is how the path looks like of your blob.name. So split, what it will do, it is going to basically break it into process. It is going to basically unpack this and store all the elements inside a list. And -1 grabs the last piece, which is just the file name itself, which is JSON. Okay, that's it. That is all what it is going to grab. Okay, then NCT ID. I'm just going to say file name dot replace. Okay, and then you replace .json with an empty string. Okay, so remove the JSON, okay, at the end to just get the NCT ID. That's all. We just need the NCT ID, so just remove this. Just replace this with an empty string. That's all. Okay, and if NCT ID, then now you take the NCT IDs and you append that to the NCT ID empty list here. So now we have these NCT IDs in the cleaner version, which are kind of tore apart from the .json file extension. Okay, and let's just log it. Yeah, so I'll just say listed processed studies count equals to length of NCT ID. So it is just going to tell how many processed studies it went through, and it is also fetched, and it is finally going to return us those NCT IDs. As simple as that. Okay, and then towards the end we are just going to write a helper function. Okay, now till now you might have seen that I am writing this function, which is upload JSON, download JSON. Now where are those upload and download JSON functions, right? So this is where we'll be writing those functions. Okay, so first and foremost, let me write a function called as upload JSON. Okay, it takes in the path. Okay, this is the path where where inside the bucket to save this file. Okay, that is the path basically. Then data. Okay, so I'll just say string and any. This is the Python dictionary that we want to save, and what does it return? It returns none. Okay, so let me just fetch the data in here. Okay, so what does this do? This is just a shared internal method that just actually does the uploading job, nothing else. Okay, every save method above eventually calls this one. Okay, so when we say upload JSON, this particular method is going to be called on that particular data. Okay, then I'm just going to say JSON bytes. Just a minute. Yeah, JSON bytes equals to JSON.dump_s data indent 2. I'll just set default to string, and I'll just encode this as UTF-8. Okay, so here let me just pull out the explanation first. Okay, so see, step 1 is what? JSON.dump_s. Okay, this basically turns your Python dictionary into a nicely formatted JSON text string. So it is basically going to take your data dictionary, going to push it into a JSON. Indent equals to 2 makes it readable. Then we're going to say default equals to string, which means if there is any value that JSON.dump_s does not know, just convert it into a plain text. And then encode UTF-8 basically converts the text string into raw bytes. And GCS needs these bytes and not a Python string. Okay, the next thing that we're going to do is what? We're going to take the blob. Okay, so blob equals to self dot bucket dot blob. It is going to take the path. Okay, so what does this do? It creates a reference to where this file will live in the GCS. So let me just fetch it here. Okay, what does this do? This will create reference to where this particular file will live in GCS. This does not upload anything yet. It is just a pointer to the destination. So it just gives the path in, like, what is the bucket path where this particular single, what is blob? Blob is a single file. So where will that single file stay within the bucket? That is what it is telling us. Okay, and then I'll just say await, and I'll just say async io dot to underscore thread. Okay, then I'll just say blob dot upload from string. Okay, then JSON bytes. Okay, and then I'll just say content underscore type equals to JSON, right? So I'll just say application slash JSON. This is how I want the output to be. Looks fantastic. Okay, so now what we do is, okay, so now we actually upload. Okay, and upload from string that you see here, this is synchronous. Okay, what we're going to do is, now this upload from string function is synchronous, so we're going to put this inside asynchronous. As simple as that. Okay, all right. The next is, now just how we have written function to upload the JSON, let us also write the function to download the JSON. So I have it created here already. Let me just take it. It's the exact same thing, just doing the download job, just how we did it for upload. This is doing for download. Oh, sorry, I think I missed out on the indentation. Okay, I hope the indentation is right here. Yeah, it's right. I'll be starting it from here. Yeah, all right, cool. Okay, so now what does this do? This basically just downloads the JSON file. Okay, and it takes the path, okay, and gives a dictionary that is in the output. If you see again, it takes the path, okay, where the file is to be downloaded, again takes JSON bytes, okay, and what does it return? If you see, it returns the JSON bytes being converted into JSON. So if you see JSON.loads, it turns the JSON text. What is JSON text? JSON bytes are the JSON text. it converts it back into a JSON, okay, and rather a Python dictionary that you can work with, okay, and then finally it takes the exception. As simple as that. It's nothing new. It's absolutely the same. Just how we done with upload, we are doing that the same with download here, okay. And that, my friends, is GCS store.py, the file that interacts with the Google Cloud Storage. All right, let's proceed with the next part, which is the final run ingestion.py, where we'll be running the entire ingestion pipeline that we have written till now. Yeah, let's meet in the next video.